Hello, good morning, good afternoon, and good evening from Helsinki. And welcome to the Pulse of Networks webinar series, episode 12. My name is Claus, and I'm the CTO of Creanord, and I'm very pleased to be joined here by Mr. Petri Savilahti, Director of Product Management and CIO at Creanord.
Hello.
Our topic today is something that is actually on every CIO's mind today: service assurance in modern cloud-based enterprise infrastructures. Let's get started. So utilizing and migrating to the cloud is something that every enterprise is thinking about today. In Flexera's State of the Cloud 2022 report, they found that almost 2/3 of the surveyed enterprises were using the cloud heavily in their daily operations already today. Half of their workloads were already in the cloud, and 6% more being migrated within the next 12 months. So it's a clear move towards the cloud. And this huge trend is quite easy to understand. The cloud offers many benefits. It's very cost efficient, as you do not have to invest heavily upfront in infrastructure that then runs idle waiting for the workload demands to pick up. Instead, with the cloud, as the need for compute resources goes up, you can quickly and efficiently scale up and indeed scale down as well if the demands decrease. It also enables you to very rapidly introduce new services to the market, as compute resources is readily available on demand, and this also accelerates the speed of innovation. With this flexible means of getting compute resources, also coupled with all of the advanced tools such as artificial intelligence, machine learning, and other tools that the cloud providers today are offering. A little bit about the terminology before we go on further. So public cloud, of course, refers to using a third-party cloud provider such as Amazon, Google, Microsoft, or Oracle, typically over the internet. And if you are using multiple of these cloud providers, we are talking about multi-cloud deployments. And in addition, if you are then also running your own private cloud alongside with using this multiple public cloud providers, we are talking about hybrid multi-cloud deployments. And as you can see from the picture, as we move further right in the picture, of course, the complexity grows in terms of managing this entire infrastructure. Despite this complexity, so it is actually a hybrid multi-cloud deployments is by far the most popular deployments by the enterprises. Again, in the same study by Flexera, they found that 80% of the enterprises actually opt for this hybrid multi-cloud deployment model, and those that would traditional companies running only a private cloud are really in a big minority. Only 4% of enterprises only have a private cloud deployments today. This hybrid multi-cloud deployment model allows the enterprises to face the migration of the legacy workloads according to the available resources and needs. And it also provides the flexibility to select which of the workloads that you run privately and which to run in the cloud. So there are clear benefits with the hybrid multi-cloud. And of course, you can further select still when you have the multi-cloud, you can further still select in which cloud you run each of your workloads, depending on of course, pricing points, but also ease of deployment and suitability of this for that particular workload. And of course, when you have multiple cloud providers, you also avoid being locked in with only one single cloud provider. So you have a better choices to migrate if you find these needs. So it is actually pretty easy to understand why CIOs opt for this model despite of its complexity. So some of the challenges with the cloud computing, there's actually a lot of challenges, of course, but just in overall, it's all about managing the entire complexity of this cloud infrastructure and the migration to the cloud. As we saw previously, so most enterprises choose the hybrid model with their own private cloud or clouds combined with the multiple public clouds. So managing all of these compute resources distributed on all of these clouds is of course a huge task and something that's pretty new for the enterprises compared to the old legacy models. And perhaps because of that, something that some of the CIOs fail to consider is the connectivity. In the old times, when you had your own private data center in the basement, connectivity was really not a big issue. But as you move your traffic to shared pipes, it starts to be the source of many of the performance issues that you may face. And in the end, of course, as you move all of this traffic onto the cloud, you need to be on top of the overall user experience. As we move along, this is not only for the human users. As you are modernizing your architecture and introduce microservices, you also need to be on top of the machine-to-machine communication and its performance. The solution to managing this complexity is to take a holistic approach to monitoring of this entire infrastructure. And you start by putting physical or virtual appliances in the office locations, and then further virtual probes or containers in your private and public clouds. And this allows you to be in control of all the potential performance bottlenecks, whether it's the office to cloud connections, office to internet, or in the case of the microservices architecture, if it is the machine-to-machine communication that is actually the issue. And having an overall monitoring solution that monitors all of these aspects and find and troubleshoots, help you troubleshoot the issues is essential. So some of the cloud monitoring use cases that this solution allows, you need to, of course, first look at the infrastructure, your DNS, DHCP services that are really the basis for any of the services to run well on your infrastructure. Of course, the connectivity, as we talked about, is many times the weakest link. So you also need to be on top of what's happening with your network and what you can do to optimize the network, perhaps increase capacity, select a new provider, change technologies that you use for your connectivity, and so forth. Of course, monitoring the internal workloads in the private cloud also allows you to set a baseline on what you should be expecting for the public cloud. If you previously run your services in the private, you get a good feel and experience on how they should work in the public cloud and can help you set the initial targets for the migration of these services. Then you have of course the public cloud services, and as said, you use the private cloud to set the baseline, and then you monitor and make sure that you also are getting the same type of service quality from the public cloud. You also have, of course, all of your public web pages and services for your end customers that you can monitor with the same solution, as well as the microservices, the machine-to-machine communication. Typically, nowadays with the microservices architectures with the REST APIs, and you monitor those as well, which is kind of the basis for how any of these other services will work. A little bit more about the measurement types that you need for this holistic monitoring. On the connectivity side, between the probes, we have actually, as Creanord introduced, optimized active measurement type to monitor the probe-to-probe connectivity, which you can then use for your site-to-cloud and cloud-to-cloud monitoring. Then for monitoring towards the internet and third-party devices, you can use GVAMP, UDP Echo, or ICMP Ping, which is widely interoperable with third-party devices. And you can use also, if you are installing physical appliances in the office, you can actually use the same appliances for monitoring the Wi-Fi quality as well, to get further see the performance of your Wi-Fi network at the same time. Then for infrastructures, it's the DNS DHCP monitoring basis of everything. When the DNS goes down, none of the services work, so you really need to make sure you are on top of that. And as finally for really looking at the user experience of all of these services, basic TCP connection monitoring to monitor the TCP performance, but even more importantly, on the web level to measure the web performance, both in terms of the download speeds and application performance. Okay, and over to you, Petri.
Yes, we'll go just through one example use case of this kind of a hybrid cloud deployment, and the use case is from one of the largest healthcare districts here in the Nordic countries, and their network consists, or their operations consist, so that they have several large hospitals around the area, and in addition to that, smaller hospitals and local healthcare centers. And they used to have so that they had two co-located data centers, which they had their own quite a lot of their IT infrastructure there, and then they deployed Microsoft Azure both to Ireland and Netherlands. Actually, they had their data centers there, and partially their IT infrastructure were there. But then, like after the introduction of this one, they had some issues, especially with the Azure in the beginning. That, for example, that they had some time to time, like over 5-minute data cuts between their hospitals and then the applications running on the cloud. And in addition to that one, that they were of course running Office 365 out of these data centers. They sometimes had issues with, for example, so that with Outlook, when you were searching for the certain emails, that was not functioning properly. So that was like the issues that they were facing, and they wanted to have a more holistic view about this one, that how then they proceeded with our Pulsar solution to tackle these issues was so that actually they deployed these physical appliances on all the hospitals and the healthcare centers, and then they deployed them as well on the two data centers, that these co-located data centers that they were running. And in addition to this one, they deployed virtualized appliances on both Azure data centers, so in Netherlands and Ireland. And from there, they established this kind of a full measurements. So between like the hospitals and the healthcare centers, between the co-located data centers, as well as with the Azure cloud data centers as well. So after this one, they were able to see that, okay, how quickly these connections or the connectivity between each of the locations was working. And actually, when they started to do these measurements, they were able to pinpoint that who to blame, or if they had this kind of cuts and issues, that they had a direct, finger pointing to the right direction, that which service provider or their own IT department to send the notice to do something about it. And I think that one of the outcomes of actually this initial deployment was also so that they realized that due to the issues that they had with the Azure, that they decided to go the whole way and actually deployed now further this one, so that they are now running with Google Cloud Platform, Amazon Web Services, and Oracle Cloud. So the IT infrastructure is split or spread to all of these four major public cloud providers, in addition to their own these co-located data centers. And they are running these virtualized appliances on all the data centers, and they really know immediately that if there is a hospital having issue with one of the like the services or these programs or applications that they are using, for example, for the or these patients or anything, that they can immediately check from the IT department that, okay, how well is the connectivity there? They can even run these TCP or web page download tests as well, so that they can be checking that, or are these applications available? And I think that this specific customer has been very pleased with our solution, and they have been able to sort out, many issues that they have had in their systems so far. All right, then I thought that I'll just go through a quick demo, and I just want to describe or show our own internal IT infrastructure. So we have this kind of a hybrid cloud infrastructure ourselves. So we have our own data center running here in our office in Helsinki. And then in addition to that one, we have some services running at Google data center in Hamina here in Finland. Some of our services running on AWS in Stockholm, and then Oracle Cloud in Netherlands. And they are actually pictured there in the network diagram. So we can see that now just in the demo that really like these are the virtual appliances running on each of the public cloud providers. And these measurements or which we are running, they really show. Now I'm going to expand this one so that actually that shows our head office here in Helsinki, and one of our branch offices actually at my home. So we are running like physical appliances on there. And now we can just open we have these appliance to appliance, these probe to probe net precision measurement running on each of the legs. We can quickly look at what is the delay variation and packet loss of each of the services. So if I have an issue with accessing something, depending on where it is, I can very quickly go and have a look on those. I mean, especially this graph. And if I then want to have like more detailed view, I'm going to show you like just in a minute that you can go and click and expand and see that, okay, for what reason, for example, the graph is red or like an other color. So this is a very neat way to do it, and very quickly you get an hold on that how well your actually this hybrid cloud infrastructure is running. So for example, here I can see that I have a pretty constant delay between the branch or office and then the Google Cloud, and that was like over the set limit of 60 milliseconds the delay. So that was actually causing the issue. Here is an other connection that's actually the other direction where we have just a delay about 50 milliseconds, so it's much shorter. But that's like quickly put that how you can monitor your own infrastructure. Then about what Claus mentioned, really like how the modern microservice applications are built. So the idea is that you have you split your monolithic large application into small services, which you can then run on, I mean, the best optimized place wherever it is. So in your hybrid cloud, you can run it so that it's partially run in your own data centers. Then you have pieces of this application running on those public cloud providers as well. And all the communication between these microservices is done using REST APIs. That's the modern way of building really the applications. So I'll have a quick demo of how you can actually monitor this one, so that we have our the main application is running actually in our own data center here in Helsinki, and then I have partially or pieces of that application running on all of those public cloud providers. And what I'm testing is actually that how quickly the REST API on our home data center is responding to these public cloud provider pieces. So let's go on. So that's like again the same setup, but in this case that we are having the test endpoints are actually there on those public clouds, and they are there measuring from each of these public cloud provider towards our own data center here in our home data center. And with that web page download, I can see that by just clicking the line, I can see that, for example, from Stockholm, from AVS, the REST API is responding in approximately 150 milliseconds. And you can always like set depending on the application thresholds for these values. So you get automatic alarms that if that value is then crossed. So that, for example, here you can see that there has been like some spikes which have been like above those ones, and then normally it's there around like 100 and 200 milliseconds, for example, for here. So this is really like how you build a modern applications, these distributed applications, and these are the tools that enables you to monitor them, so that immediately that you get an alarm that if the thing starts to go wrong, which will then have a total effect on how the customers perceive the functionality or the service that they get from these distributed applications or application.
Okay, thanks, Petri. So to conclude, so as we noted, enterprises are migrating many of their workloads to the cloud today. Something that's many times overlooked, the performance of the connectivity is many times the weakest link, and so you need to be able to monitor this connectivity, but you also need to be able to monitor your whole digital experience in terms of both on the connectivity layer, but also infrastructure application layers. And with the Creanord PulseShore solution, you get a solution with all the functionalities that you need to capture this digital experience as you are migrating to the cloud. So the PulseShore solution, it's a full solution with both physical and virtual probes of different sizes that you can deploy in your sites, in your data centers, in the public cloud, supporting all of the major cloud providers. We have the PulseScore solution, all-in-one management solutions, which offers you holistic view of all of the performance with analytics, advanced analytics, so you can troubleshoot and find the issues among all of that data. When as you saw, there's quite a lot being monitored, but with that thresholding, alarming analytics, you can then find your bottlenecks and resolve them. And we have tools that covers all of the service life cycles. So both when you are taking new services into use, we have service activation testing, we have the active monitoring, user experience, passive monitoring, application level monitoring to cover all of your monitoring needs. We are very good at being technology and vendor agnostic. So we are interoperating very well, both in terms of running our software on different types of third-party hardware and hypervisors, as well as interoperating in terms of the measurements. And we have deployed this solution in more than 60 service provider networks all over the globe. Okay, so that's everything we have time for today. So if you had any questions, please send us an email. You have our contact information at the bottom of this last slide. Please go to our website. We have a lot of other webinars on interesting topics, all aspects of performance and service assurance. Stay tuned for our next webinar, and please don't hesitate to contact us if you have any questions. Thanks, everybody.
Thank you.